All right, it's time for the other side of the same coin. 6.4 to 6.4.1. Anyway, 6.4 talks about conventional loans. So these are the loans that we usually talk about for cars and for houses, like mortgages and stuff. Okay. This does not apply to payday loans. It does not apply to add-on loans. Those are pretty bad, by the way. I was reading more about payday loans before recording this video. They're basically short-term loans with insane interest rates. Like credit cards, a lot of credit cards have like 12, 15% APR or something, which, you know, can be a lot if you don't pay off your credit card debt. A lot of payday loans are like 300 to 400%. Yeah, you heard me right. 300 to 400% APR. They're illegal in some states, and they really screw over the borrower. And sometimes, you know, people feel like, or people have to take them. I don't know their own situations, but yeah, it's pretty rough. Add-on loans are kind of similar. Anyway, we're not talking about those. We're just going to talk about conventional loans. Think car loans, home mortgages. All right. So here's the loans formula. It's, all right, principal, all right, P equals some number times 1 minus 1 plus R over K. Jason, you made 2 mistakes. You said we're still in 6.3. Maybe it wasn't a mistake. This is the same formula. This is the same formula. We are still in 6.3. I tricked you. You're never getting out. All right, the loan formula is the same formula as the payout annuities formula, just from a different point of view. Okay, right? If we replace this with a W, then it's the same exact formula. All right, and think about what a payout annuity was, right? Payout annuity is there's this big sum, and we're lowering that big sum every month, but it's still growing because of the interest. Wait, but that's exactly what a loan is. You got a big loan at the start. You're paying it off slowly, but that interest makes it keep growing. So when I said that these are 2 sides of the same coin, payout annuities were the good news. All of those great news about how much money you actually have turns into bad news here for how much money you actually have to pay. All right, so it's the same formula as payout annuities. We can call it PMT for payment if you want, but really it's just the same formula. So let's look at this. Again, this is the same formula if we really write this down. Same formula as payout annuities, because it really is the same thing, just from a different perspective. Let's get into it. Let's say we're buying a car. You calculate and you say, okay, I'm doing my budget. I can afford a $300 a month car payment. And you go to, you know, whatever your used car dealer or whoever, and find that they'll offer you a 4% interest auto loan for 5 years, 60 months. How expensive of a car can you afford? In other words, what loan can you pay off with $300 per month? Well, let's use this formula. P, the total amount that gets paid off over T years, is going to be your payment times 1 minus 1 plus R over K to the, to the negative KT all over R over K. Let's find out what everything is. We can afford our payment to be $300 a month. The car loan, 0.04. T is T 60 or 5? Careful. Let's skip that for a moment. K is how often our payments are. K is 12. So we're already taking into account that it's happening 12 times a year, right? That happens right here. We already are taking that into account. So that tells us that T has to be 5. T is the number of years. T is always years for these. Now we just plug things in and find what P has to be. 300, same calculations as last section. 1 plus R over K, the negative K times T, all over R over K. What is P? Let's find out. So we go over here, and I'm just going to copy this. 300 times 1 minus 1 plus 0.04 over 12. The negative 12 times 5 all over 0.04 divided by 12. We do a double check. Make sure it matches. Make sure it matches. Looks like it matches. 16,289.72. All right, we can get a pretty nice car. All right, we're not buying any Ferraris. But if we're buying a used car, yeah, I can give you a pretty good used car. 300 a month for 5 years. There we go. That's how we do it. Basically the same formula. Things just look a little different. All right. Let's buy a house. Buying a house is great. I recently bought a house right after housing prices just went sky high through the roof. And I'm in Washington State, so that's not great for houses either, but not as bad as some places. So we want to buy a house. It's worth $400,000. We didn't put a down payment, so we're going to take a $400,000 mortgage. The interest rate on this loan is 7%. Interest rates are not great at the time that I'm recording this video. And it's a fixed rate 30-year mortgage. All right, those usually have the best interest rates, most reliable. You don't have to worry about your mortgage changing every month, like adjustable rate mortgages are. There's also like 15-year mortgages and stuff like that, but your mortgage payment's a lot higher. Although you do save money in the long run. Anyway, how much will your monthly payments be not counting PMI? You don't really need to know what PMI is, but if you're curious, PMI is called private mortgage insurance, where if you don't have like a big enough down payment, then essentially your lenders are nervous. And so you have to pay them extra money every month to kind of compensate their risk for making sure that they're not going to be stuck with a bunch of you not paying things off, basically is what it is. It's all about risk, and it's a lot of money. I'm currently paying PMI myself. Anyway, let's do the problem, okay? So we got the formula. P is your payment times 1 minus 1 plus R over K, the negative KT, all over R over K. I hope you're getting sick of writing this, but it's really, really helpful whenever you use a formula to copy it down, and then we just fill things in. All right, so we know P, that's going to be the loan at the start, the amount at the start that we got to pay off. All right, interest rate, 7%. Fixed year, 30-year mortgage. Okay, we can pay off. We're paying off that $400,000 in 30 years, and we're doing monthly payments. Okay, is 12. Just fill in the blank. That's it. So 400,000 is equal to payment. We don't know our payments yet. That's what we're trying to find. We're trying to find the monthly payments. 1 minus 1 plus 0.07 is getting split up into 12 pieces, and you're paying that interest every month. Minus K times T, which is 30. We're not even to the most depressing part of this section yet. That's next. It's right down here. All right. 0.07 divided by K. All right. And again, just like in the previous section in 6.3, this big red box is just a number. It can't hurt you. All right. So the next line becomes 400K is equal to our payment times our big red number. Find that big red number. 1 minus 1 plus 0.07 over 12, negative 12 times 30, all over 0.07 divided by 12. All right, big red number is about 150.3076. Now it's not too bad of an equation to solve. All right. Let's divide both sides by that 150 and find out what our monthly payments are going to be. Our monthly mortgage payment, if we want to buy this $400,000 house, it's going to be a lot. Don't I know it? Don't I know it? All right. So 400,000 divided by 150.3076. That is, you can't see it because my head's blocking it. My head's trying to save you guys. It's $2,600 a month. Woo, let's go buy a house. 2661.21. Yeah, buying a house was a lot nicer before interest rates and housing prices skyrocketed. I talked to some of my friends. Never ask. Should never ask my friends who've had a house for like 5 years or longer what their mortgage payments are. It's so depressing. Let's make things more depressing, okay? So for any future home buyers, maybe the market will change. I mean, it's going to change eventually, but right? Anyway, so an amortization, and again, that's how you say it. It looks kind of weird. Amortization. Amortization schedule is a spreadsheet that shows the details of a loan payoff. And conventional loans, I say remember, but I've never actually told you this. So I'm just going to say this is true. You don't have to remember it. Conventional loans are sometimes called amortized loans. Just means you're paying it off over time, basically. So there's a link to, wait, can I not click on the link? I can click on the link. Great. It opened the link in Outlook. It tried to have me write an email to this webpage. It's ridiculous. Okay. So, all right. So here's an example. So let's type in our last example. 400K, 30 years, no down payment, 7% interest. You can calculate it. Here's our amortization schedule. Okay. It shows after every year, how much interest is left. And wait, hold on. I'm losing my mind. How much interest are you paying? And how much are you paying off on the actual loan? We can see a graph here on this website. Red is your payments over time. It's linear. We're paying the same amount over time. Blue is actually the balance of your loan. It started off as 400K. Green is how much we've paid in interest. Let's look at the monthly schedule. We said every month your payment's $26.61. Does this agree with what we said? Yeah, $26.61.21. It agrees with what we said. All right. And look, the first month, you're paying $26.61. $2,333 of that is just going to interest. You're only actually paying $328 to actually lower the loan cost. You're only actually paying the first month. You're only actually paying $300 into your loan. The whole rest is interest. Okay. And then as time goes on, notice our interest payments get less because there's less loan remaining. And so if we like really go into the future, okay, look, after 11 years, wow, now we're paying $700 towards our loan and only $2,000 of interest. So I had a lot of fun buying my house, doing a lot of the math for this because there's a lot of interesting math problems. There's a lot of places we can go. A lot of lenders will like offer you deals of like, oh, if you pay this more up front, we'll change your interest rate. And it's like, okay, well, how much does that change my payments? How much does this change the total amount that I pay? Depending on how long I have the house too. Like, am I actually going to be in this house for 30 years? Probably not. And that sort of stuff. Also, remember that this is a $400,000 house. This is how much we're actually paying for the house. we're paying $1 million for this $400,000 house over time. Okay. 558,000 of that is interest. Yeah. So there's a lot of interesting math that goes into buying a house. And now you know some of it. Okay. So let's look at example 4. And all right, let's end this video on a good note. All right. Look at example 4, the same situation that we're looking at with the amortization calculator. We just did that. Now compare our situation. Let's say we have a crazy rich uncle. And let's say our crazy rich uncle is giving us $1,000 every month for our mortgage payment. Thanks, crazy rich uncle. So now, instead of paying $26.61 a month, we could pay $36.61 a month. How does the amortization schedule change? How does our loan kind of change if we're paying an extra $1,000 every month? It's going to be great. Big change. All right, first off, we're getting $12,000 a year. That's great. And second off, look what happens. So we could do this by hand, by the way. Do this by hand and just adjust PMT and P, and we could solve for T. That's an exponential equation. Let's look at what this is. So let's say we're taking out the loan right now, and we're doing an extra monthly pay of $1,000. All right, not extra years, not extra one-time pay. Check this out. Now, we pay it off in 15 years, half the time. Okay? And now the interest is not $550K anymore. The interest is only $238K. This saves us $300,000 in interest. A lot of money saved in interest. Okay? Even though we're only paying this much extra every month. All right, so we're coming out way ahead. So here's a solution. If you want to save money, just be rich. The richer you are, the less money you have to spend on interest. Okay? So I've solved all of your financial woes. I'll write a book about it. Okay? And you know, the joke is there. But all truth aside, right? The more that you can put up front, more up front whenever possible is going to really save you in the long run. Obviously, we can't all do that. I have an expensive mortgage myself. So, but just food for thought. And here's how some of the math works out. So you could have written down what I said, but it's not that important. It's just some context. Anyway, good luck. Sweet dreams. Hope you have nice dreams tonight thinking of mortgages. Bye-bye.